लाइव हो गया। गुड मॉर्निंग। So what's your name? Huh? Yeah, I said good morning. I said, what is your name? Oh, acha. Okay. Thinkashi. So, good morning and welcome. Yeah, Swamit Biswal. Good morning. Welcome to the live session. Yes. So, you can write your queries and we will see if we can answer those. Okay, so what is your query for the air breathing propulsion question? Can you write what is it that is not clear to you? Okay. Uh-huh. Okay. So you're looking at relative awareness of air breathing system. So primarily when we talk about air breathing system in the context of rockets, one thing which we are looking at essentially is that your oxidizer you don't have to carry, and that is the reason why it becomes lighter rocket. Propellant can still be the same. It is the oxidizer. See, when we talk about the air breathing propulsion, what we are trying to do is we are extracting oxygen from the ambient air. Propulsion or propellant, as you are asking about, the propellant in many sense for the rocket is a combination of the basic propellant plus the oxidizer. So if you look at solid propellant, it will be a combination of an oxidizer and something which will burn and generate the energy. Now, when we talk about air breathing propulsion, what we are saying is that the oxygen part is we are not going to carry with us, or we are not going to carry anything which is the oxidizer. What we are going to do is we are going to generate the oxygen from the ambient air, and using that, we can reduce the starting mass. And that is what is the intention of that course. Now, you can, of course, do many more things with the air breathing propulsion. But this is the primary objective with which the air breathing propulsion is configured, that you need not carry oxidizer. I hope that point makes sense to you, both Swamit and Tekashi. What is the answer suggested? That it will be lighter rocket, right? No. What was the answer suggested? Can you tell me?
Answer is larger thrust and lighter rocket. Two of them.
Ha, correct. So it is larger thrust and lighter rocket. So you are saying it is A and C. What is the C option?
A is larger thrust and C is lighter rocket.
So, strictly speaking, larger thrust is not really applicable. What is applicable is the lighter rocket. Yes, you are right. That thrust will depend on the amount of propellant you are carrying from a mission perspective. So it has really nothing to do with whether it is air breathing or not air breathing. What will be the correct answer would be C. That is, it should be a lighter rocket. Now, the question is that this is a very, very specific aspect of the overall rocket design. The point which I'm trying to make is that if you save on oxidizer, it is possible that you may increase your payload mass and not really have a lighter rocket. So that aspect we are not examining at the moment in this question. But from a general perspective, typically when we try to configure a space mission, whatever saving that we do at any point is translated either into an additional payload that you would like to carry or a larger energy mission. Not fuel consumption is not small. This is, I think, this is where you have a confusion. It has nothing to do with fuel consumption per se. The very basic, simple idea is that because you are not carrying the oxidizer, that much mass is saved. Simple, nothing else. It's nothing like a smaller size. Because these are the parameters which have nothing to do with carrying oxidizer. The only point which this question is trying to put forward is that if you don't carry oxidizer, that much of mass is saved, and that is what makes the rocket lighter. No, not really. The specific impulse is directly in the propellant. See, specific impulse actually depends on the exhaust velocity of the propellant, and it's a propellant chemical property. It is not really related to whether you carry oxidizer or you do not carry oxidizer. No, I didn't understand this formula for assignment questions. Can you clarify a little? Because all the formulas are part of the videos where these all slides are presented. So all formulas are there. No, I think that question that fuel consumption is less, not really so. See, we want to differentiate between oxidizer and fuel. So the fuel remains the same, or it could be any quantity, it does not matter. What matters is that because you are not carrying oxidizer, to that extent, your mass is less of the overall rocket. That's all, nothing more. There are no other aspects that we are examining in that question. Uh-huh. Okay, so let me clarify this question. Your actually the specific impulse is your velocity and gravitational acceleration, which is the reference value. These are only two quantities, and that velocity is the exhaust velocity of your gases, and that has not. So basically, it's a kind of a propellant or the fuel engine combination, depending upon the design of the engine nozzle, injectors, and the kind of flow patterns which are their temperatures which the fuel has reached. So essentially, it's a thermodynamic process. Specific impulse comes from a combination of a thermodynamic process and an aerodynamic process of the flow which is going through the nozzle. And by and large, it's a constant. That is why ISP is given for a propellant directly. Typically, for solid and liquid propellant, this number is given as a combination for the propellant, which is combination of fuel and oxidizer. Always you will find that these two go hand in hand. Previous year's question papers. No, we don't do that. Because this is only apparent. See, I understand your point that you are looking for kind of a question paper pattern. But I thought the pattern yeah, no, no, that is weight flow rate, not weight. It is weight flow rate. Please note. The rate at which the propellant is burnt is what is. So this is actually, if you look at thrust expression formula, it is m dot g naught ISP. That is how the, so if you look at ISP, it is thrust divided by m dot g naught. It is not mg naught. So it is not weight, it is weight flow rate. The rate at which you consume the weight of the propellant, that is what it is. So it is not weight really, it is the rate at which you are consuming. And that is essentially purely a thermodynamic process. Because rate at which you are going to burn will depend on the flame propagation and those kind, what is the temperature at the interface. Impulse by weight is same as, now I don't know what you mean by impulse. Typically the impulse which is considered is in the form of velocity. So it's a velocity impulse. So then ISP would be velocity by G naught. Maybe you need to kind of look at that. There is a derivation which is done in the propulsion model in the initial lectures. I don't remember which lecture it is, but there is a propulsion model where it is explained what is the actual way in which the ISP. So ISP is a figure of merit for the fuel oxidizer combination. Okay, so what we are essentially talking about is this is what is called momentum then, not really impulse. So this is the momentum. Mass into, so this is equivalent to mass into velocity once you say thrust into time. The units, if you look at the dimension, it is mass into velocity. So it's a linear momentum basically. Which is right. I mean, so, but the issue is that you divide this by weight flow rate. Would like to.
I would like to take those questions regarding previous year question papers.
Uh,
So as a policy from NPTEL doesn't publish any previous year question papers, but you may practice with the assignments of the available on the course portal, which you have gone through. And as my previous experience as a student at NPTEL and as a TA, teaching assistant in other courses, I would like to give you some tips regarding to preparation for the final exam. You can go through all the assignments, all question paper all questions available in the assignment one by one, do the detailed calculation and got the results, and you go through the entire content once again. If in the form of videos you can go through, it will be very helpful. If you do not have time to go through the lecture content again, so you can go through the text transcription files available on the course portal, where you will get the course slides as a screenshot within the document, and you can also go through the verbatim which professor has said while delivering that lecture. So you will get the screenshot of the slide in which he has mentioned anything. You will read at the down side of the document, and you can go through those documents before appearing for the exam. So this will benefit you in terms of preparation, because there is no need to go through the previous year question paper, because the questions will be different and the concept will remain the same. So you will get the concept from the content only. So you need to go through the content again. You need to go through the all the questions in the assignments. So with this preparation, it is okay to go for to appear for the exam. So you will be able to do that.
the only thing I know that's what he has said is quite a lot because you have only 2 days left for the exam, right?
Yes.
27th is the exam and today is 24th. So it's going to be a race against time. But if you have been regular, if you have been going through the videos and if you have been solving the assignments, I think it should work out by and large. And with regard to the overall pattern, I think NPTEL does publish the overall philosophy of the question paper. So that must be available somewhere, right?
Yes. So on the course page, you can see the how much marks you need to get pass and got the certificate in the final exam and as well as in the assignments. So you will get the weightage of both of them, and you need to clear the criteria of both of them to get the certificate for the exam.
So I mean that is the primary, but I would say if you have understood the most of the concepts and you are reasonably okay with the various mathematical relations, the expressions, the derivations, it should be okay. Many times what will happen is that there might be some confusions on concepts, some small lack of clarity in some ideas. For example, the point that you raised about the air breathing. So that probably kind of requires a little bit more of, I would say, closer looking at, particularly the way, see, many times what you will find, let me give you one, just a I wouldn't call it a hint, but a thought process, that many times the answer partly is hidden in the way the question is framed. So there will be manner in which the question would be written that would kind of exclude some kind of answers. For example, it would suppose there would be terms like in general, usually. They exclude all the specific cases. Which means you need to look at problem from a general overall perspective. You cannot pick a specific case and say that this case should be this. No, it doesn't work like that. So I just thought I will make a mention that reading the question carefully and maybe kind of thinking about this as to the way the question is formed, what topic it is concerned with, what aspect it is examining, it should probably help you to kind of come up with the answers. This is only for some of the questions, not all. Some are plainly simple application of formula and getting the numbers. So in those situations, what is important for you to realize is what formula is applicable for a given case. Yes, correct. Generally, trajectory of steep ballistic end. Correct. So the other point which I wanted to mention is that it is important for you to realize what formula is applicable in a given case, or which physical effect is being examined. So what is the mathematical representation of that physical effect? For example, if I say, that how is the procedure to write the exam? It says online, you are provided answer sheets. So that.
So you will be getting some rough sheets,
Hmm.
and you will have to hand over at the end of the exam. So you don't need to carry anything apart from pen or something, and please carry your admit card, hall card, and you reach to the venue before the time, and you will be admitted to the
Because I
center.
think even the calculator is available online.
Yes.
In fact, there is a standard calculator which is what you are supposed to use. You are not supposed to bring any of those other things to the examination hall.
No device, nothing.
Nothing.
So you just need to reach the center. You will get online calculator on screen where you need to do the calculations, and you will require any rough sheet or anything you need to write and solve anything. So you will get rough sheets, and you need to hand it over back to the invigilator while you leave the exam hall. And
I think on those rough sheets, probably you will have to write your what do you call, registration ID or whatever the exam ID that is going to be issued to you. Just for the sake of record and identification. So the only thing you probably need to carry to the examination hall is your preparation and knowledge. So I think it is important for you to realize that a careful reading of the question and identifying the physical principle underlying the question is what you need to correctly interpret. Once you get that, then I think the remaining is only a matter of detail, and if you are reasonably prepared, it should be fine. I hope that kind of at least kind of reduces your anxiety to some extent. I know all exams are always like that. We are always anxious about the exam, what kind of paper. See, ultimately, a paper cannot be too different. It has to examine the principles that have been presented and discussed. Only thing is that the way they are worded, the way they are kind of combined, linked to each other, is what can be something which probably you need to understand. So, any other point that any of you would like to raise?
Also, I would like to add to this, as you were asking about the answer sheets. So those are the rough sheets. Those are not going to be graded or checked or anything. No. So you need to fill your answers in the portal. So that only going to be automatically graded. So you can write anything on that paper in rough way. So don't write very beautifully that as an answer sheet, which is going to be evaluated by the person. Not like that.
Yeah, you know, is it 1 mark, 2 mark, 5 mark? How is it? That I'm not sure what is the policy of NPTEL, whether those are the kind of things which are available, because this is something which I think is in the purview of the question paper itself. So until the question paper is out in public domain, when the people are answering it, it would probably not really be provided as a kind of, I mean, there could be a combination of all these. That is what my feeling would be, but I wouldn't know. I mean, this is entirely in the context of what, how the NPTEL then configures the question paper, and once it is released, probably you would know. So, is this introduction to analysis? Okay. As of now, there is no second part. Typically, the second part of this course is orbital mechanics. And I think on the NPTEL portal, there are many courses which already are running, which talk about orbital mechanics. So, in case you would like to know what happens after the ascent mission is over and the rocket has done its job, then probably you could register for any of those courses which talk about orbital mechanics, interplanetary travel.
Hmm.
Uh,
So there is one more question on the
uh,
Excel sheet. After the completion of this course, what should be our next step?
mhm.
What next NPTEL course should we enroll for? What more skills knowledge should we target?
Huh. So, I mean, as I was mentioning just now, the primary, if you are looking for, I mean, if you have more interest in space-related activities, then I would say the logical next step would be to go for uh, their orbital mechanics course. That is what I would suggest. There is another one, applications of booster stage design, which is the gravity turn approach followed. Okay, so let me clarify. What we did as part of this was something which was essentially a simplified synthetic version of a general, what is typically called a trajectory design approach followed by any of these space agencies which are designing rockets. It is possible that a trajectory which uh, has been ultimately designed and configured may have parts of these spread over the complete trajectory in small segments. But in general, what people do when they are looking at a realistic mission, they will solve the nonlinear equation in a numerical manner. They are not going to make such simplifying assumptions that we have made. In fact, if you look at the gravity turn, we have not really explicitly brought in the effect of aerodynamic drag. It's only the gravity that we have considered. We have also kind of simplified our approach in order to understand the basic physical effects and get an order of magnitude idea. And we have given simplified gravitational models. But when you are talking about a complex space missions, you would code the most general complex, which will have the Earth's curvature. It will have Earth's rotation about its axis. It will have the Earth's gravitational model, which will not be the spherical symmetric model that we are talking about. This model will be a lot more complicated with oblate Earth, ellipsoidal models. So you will find that your mathematics is going to get a lot more complicated than what we have as part of this various derivations that we have done. And once you go through that, it would be difficult to find a connection between the simplified gravity turn trajectory solutions that we have obtained and the actual trajectory solutions that one is going to obtain. So I hope this point is making sense to you, that what we have done as part of this essentially is a very elementary classroom exercise where we are just trying to kind of understand that if we did it in such a simple manner, what is it that still we can get? Can there be anything of practical value that we can extract out of it? Is this making sense to you, Somit? Or do you have something more to add? It will be useful combining the rocket propulsion and what is that? Fire dynamics? I did not understand.
Maybe flight on, if it is a type.
Oh, okay. That Prajwal, I am not able to understand. Fire dynamics. If I can understand, yes, you can definitely go to a detail of rocket propulsion. Well, I already mentioned this, saying that uh, be well prepared, go with a cool mind, and couple of tips like reading the questions, interpreting it correctly. Sometimes there are issues that we think we have understood, we have interpreted correctly, but that probably is not the way the question is to be interpreted, and that leads. So spending time with the question and understanding it in the context would definitely go a long way in helping you score good. And being well prepared, there is no substitute for that. So I'm still not clear about the fire dynamics. Are you talking about liftoff maneuver? So yes, but there are not, I think, too many courses available which talk about it. This essentially goes into launch vehicle operations technology. So there are not many courses that people are running at the moment which talk about launch systems like your launch towers, how the liftoff is managed, then what are the related communication technologies like telemetry, tracking, telecommand, getting the data, keeping track of this. So there are a large number of technologies which go into even a launch mission itself. What we have looked at is a very, very small segment which essentially talks about its mechanics related perspective. That probably is what I would like to say. Oh, yes, definitely. That is a given because problems are based on theory, so theory cannot go anywhere. It's always there. So your conceptual understanding of what the whole idea is, and then ability to, what is that theory of fire propagation? Oh, so are you talking about the combustion part of it by any chance? The flame dynamics, which talks about how the propellant will burn. If that probably is the question, then this goes into the design of the propellant grain, particularly in the context of solid propellant, and in the context of liquid propellant, it essentially is the fuel injection system. When we expect to see questions on nozzle design, I'm not too sure of that for the reason that I don't think as a part of the course we have done any nozzle design. If you go back and look at your propulsion model that we have used in our basic understanding of the mechanics of the ascent mission, we have used this as uh, something like a placeholder, a black box. For us, propulsion is just a thrust, which is related to your rate of consumption of propellant and a propellant ISP, and we have left it at that. So we are not really looking at nozzle design per se. Of course, it comes indirectly through the pressure thrust, which is part of our ISP definition. But once we combine it with ISP, it is not there. So the concept of chase orbit was not very clear. If launch happens when the target satellite is above, won't we be far behind? No. So this is something which probably is not very intuitive. Even though what you are, yes, good morning, Emilio. What I'm trying to answer this Swami's question, which says that chase orbit. So the whole idea of chase orbit is that when you are chasing, now it is just like any concept of chase. For example, when you are trying to chase your friend, you run faster, right? Once you accept that idea that you are going to uh, run faster in the context of space missions, the faster run is when you run from behind and you run in a lower altitude orbit. So automatically you get larger velocities. So you are able to catch up with the object which has already passed. And once you reach in a reasonable distance, there are typically what is called rendezvous missions. See, space shuttle is an ideal example where the space shuttle docks with the space station. So it typically goes in that chase orbit. That was the context in which that particular topic was mentioned. I hope, Swamit, that is making sense to you. There is something on Hoffman's, I didn't understand that part.
Transfer orbit, I guess.
No, so that is different. That you go to orbital mechanics. So that is what I would say. That see, when we talk about these chase orbits, we are also talking about missions which are already what we call the SSTO or TSTO, what we call the single stage to orbit or two stage to orbit. Well, typically that is why if you look at your various space missions and currently what we have talked about, we are not really putting too much premium on the time taken. We are willing to wait for the time. And if you look at really the satellite which is in the orbital time periods are quite large for in particular. Whereas your typical ascent mission, if you are talking about a fast transfer, that's why these are also called fast transfers. They are not slow. They are not really optimized to minimize the propellant consumption. So your actual mission, that is chase mission, will get over in 15 minutes. And in the spacecraft which is in orbit, the 15 minutes is nothing. This would have a time period of maybe days or maybe hours. So it's not really that critical, particularly because there are no specific locations by which or by time by which you must have a connect with the destination. But when we talk about interplanetary missions, for example, going to Moon or Mars, then these things become very critical. So you have to be very careful. Assignment 4 was hard. Why would you say so? I thought all assignments were hard. Why only 4?
Yes.
Right? I thought all were hard.
We will take as a feedback
Ah,
for the next time.
correct. So if you say this only 4 is hard and others are soft, I know where I should work to make them harder. It's on the lighter vein, of course, but then sometimes what happens is that depending upon the subject matter and the physics that we are trying to capture, I would say go for either a course on space propulsion, which would clarify a lot more doubts on your propellant and other kind of technologies, or go for orbital mechanics and interplanetary travel. Completion of the, can you please suggest next course? Currently in the 4th sem of aerospace engineering. I would say aerospace propulsion you would have already done. If you're not done, I think that would be a good course to take a space propulsion. Or you could go to orbital mechanics. There's another possibility of what you call spacecraft attitude dynamics and control if such a course is running. Because there you can talk about Earth observation. Then, for example, things like TV transmission, your GPS, navigational satellites. So essentially, if you take the next set of courses in the domain of spacecraft technology, I think they should be helpful. Any other point any of you have? No, I'm really, I mean, not very happy with this mode of interaction, which doesn't let me see you even though you are able to see me. So we are hoping that in future, if there is such similar interaction, we would probably be looking at each other so that we know whom I'm talking to. So
I got some queries on the discussion forum as well, recently, yesterday or the day before yesterday. So someone asked that he has registered for 12-week course, but no, this is 8-week course. So there will be no 9 to 12 assignments and course content. It is only up to 8. And now you are about to get your exam in.
That's why it started in February, if I remember
Yes,
correctly.
yes.
It became live on 17th Feb.
Yes.
Went up to, I think, 14th April or when?
Yes, last week.
Last week.
So you must have some missed up on something course content or course introduction part. So
It's an only 8-week
yes,
course. It's not a 12-week course.
Next queries which I am getting on the discussion forum regarding the detailed solution of the assignments problems. So we don't actually want to spoon feed you. So you get the content first, you try to approach correctly and you try to do the solution from your side. If you are getting stuck in between anywhere, so then you can ask us, okay, I am getting stuck in between at this step. I'm not getting this number which you are getting as the final answer for the question.
So you might get possibly a hint as to how to get around that hitch which you have kind of encountered. The implication is that by looking at the video, the lecture content, the derivations, you get to. You're talking of Prajwal, LinkedIn. See, I'm not on LinkedIn. I'm an old man. So I've kind of, I'm not even kind of in sync with these kind of modern technologies. My feeling is that NPTEL would probably have a way of putting this connection that you remain connected with people whose courses you have undergone. What I can do is that I can check with NPTEL office and see if they don't have such a mechanism by which there can be a kind of a continued connection and interaction in future. But at this point, I'm not really aware that such a thing exists as far as the NPTEL overall format is concerned. I hope you understand.
During the run of the course, it is available as a discussion forum where they can get connect. After completion of the course, we need to check.
See, I think during the course, there is not a problem because as long as the course is active, any question that you post on the discussion forum will get answered.
Yes.
So we are assuming that you are looking for these answers while you were solving those assignments. And in case you have asked a question and you have not got an answer, then it is a failure on our part, which we will look into as to why we were not able to answer your query if you raised it while the course was still continuing. Once the course has closed, it is possible that the NPTEL would kind of close the discussion forum where you can post your queries. So this is only one mechanism left where some questions can be, but at this point, it is not really possible to provide detailed solutions to the questions. I think objective of this interaction is to clear top level conceptual doubts, overall issues of the course and the subject matter topics. So in that sense, I think it is a little too late to seek such clarifications. So, but the other point, whether once the course is over, can you connect with the course? I think NPTEL will have to enable, we'll have to find out. Okay. So this questions, see, It's not really 110 kilometers. It's only a kind of a ballpark figure. And this is something which is based on the Earth's geometry. If you look at the Earth geometry, 110 kilometer distance over the surface of Earth roughly corresponds to 1 degree change in the direction of gravity. Now, the question is, depending upon the context, you have to assess whether that 1 degree is important or not important. For what purpose are you performing that analysis? When we are talking about detailed, what you call numerical generation of trajectory by the space agencies, they will even worry about 1 second of angular difference. So they will do a lot more rigorous modeling and capturing of this. So they will not do this simplified analysis what we have done. But the reason what we are trying to bring in this idea is to generate an ability to conceptually understand that in a gross manner, number is only indicative. For example, whether the altitude which I reach is 350 kilometers or 347 kilometers is only incidental. To me, the fact that it is coming within that ballpark by doing a simplified analysis gives me a lot more understanding about the physics and the corresponding mass that I'm able to map onto the physics. I hope, Sumit, that point is making sense to you. Incorporation is very simple. It is just a change in the direction of the gravity. So if you just do the spherical Earth model and use an axis radius vector, it is just the angle between the two radii vector. That's all at local horizon. Any other point? I think we are coming to the close of the session. So if you have any more points, you can raise it. We will try and clarify. So it seems to make sense to you. I think that's probably has served the purpose of answer. No, I think we'll try to do as much as possible through the remote mode, but if we sit across table and then discuss, probably there is a much greater connect with the topics. So any other point any of them are raising now? Numan?
No,
I said, we have cleared everything?
yes.
Okay, so if there are no more questions, then I think we can probably consider it kind of done, because I don't think anybody else would be connecting now, right?
Yes.
They all would have connected at this till this point. So we can close it.
Yes, sir.
So you can call when you can. I think now we can close, right? It's almost, we have taken almost 45, 50 minutes. So we just end stream. End stream. So we're done.
Yes.
Right.